In this video, we are going to talk about determining the required sample size to give a confidence interval with a specified margin of error. Okay, so here what we want to do is we want to set the margin of error up front. Okay, and then what we want to do is to calculate and also the confidence level as well. And then what we're going to do is calculate using this formula how big our n should be, our sample size should be, to guarantee that we get a margin of error, right, of that given value. Okay. All right. So we're going to just looking at the formula, right? Here you can see that the value is given by z of alpha over 2 times sigma divided by the margin of error that we have here. And so how does this formula come about? Well, it really just comes about by solving. If you go through and look at the formula for the confidence interval, right? X bar plus or minus z of alpha over 2 times sigma divided by square root of n, right? If you solve that for n, right, roughly speaking, you'll wind up with this formula, okay? And I'm not going to go through the steps of doing that. I'm just going to show you how to use this formula. Okay, so let's take a look at example 8.84. It says J. McWhorter et al. Of the College of Health Sciences at the University of Nevada, Las Vegas studied physical therapy students during their graduate school years. The researchers were interested in the fact that although graduate physical therapy students are taught the principles of fitness, some have difficulty finding the time to implement those principles. In the study published as an evaluation of physical fitness parameters for graduate students in the Journal of American College Health, a sample of 27 female graduate physical therapy students had a mean of 22.46% body fat. Assuming that percent body fat of female graduate physical therapy students is normally distributed with standard deviation of 4.10, determine a 95% confidence interval for the mean percent body fat of all female graduate physical therapy students. All right, so let me write all this stuff down, which I probably should have done before we started, but that's okay. All right, so this is problem 8.84. It says a sample of 27 female graduate students, right? So that's n equals 27. Then it's the mean x bar was 22.46, and sigma in part A is 4.10, and our confidence level is 95%. All right, so that's what we're looking at. We want the confidence interval, so we know it's x bar minus z of alpha over 2 square root, or sigma divided by the square root of n, to x bar plus z of alpha over 2 sigma divided by square root n. All right, x bar is 22.46. Z of alpha over 2. We have a 95% confidence interval, so we could look that up here. Right, that is 1.96. Sigma is 4.10 divided by the square root of the sample size. Sample size is 27. All right, so we go and calculate that out. All right, 22.46 minus 1.96 times 4.10 divided by the square root of 27. I believe it was. Just double check. 22.46, 196, 4.1, 27. All right, so we get that our confidence interval is from 20.91 to 24.01. Okay, next up is Part B, obtain the margin of error for the confidence interval you found in Part A. Okay, so we know the formula for the margin of error, right, is z of alpha over 2 times sigma divided by square root n. So that's going to be 1.96 times 4.10 divided by square root 27. Okay, and that's going to come out to be 1.55. All right, and that is percent body fat. All right, part C says, explain the meaning of E in this context in terms of the accuracy of the estimate. Okay, so what that means is that we are 95% confident that our margin of error in estimating mu, the population mean, is at most 1.55, and that's in percent, right, body fat. Okay. All right. So next up is part D. Part D says determine the sample size required to have a margin of error of 1.55% body fat with a 99% confidence level. Okay. Okay, so I am going to erase this part. All right, and we'll just have to remember that z of alpha over 2, oh no, actually that's going to be different. Sigma is 4.10. Okay. All right, so here we go. Okay, so in part D, we want to estimate the sample size, right? So that is going to be this formula that we talked about, n equals z of alpha over 2 times sigma divided by E, the margin of error, quantity squared, okay? Okay, and so now figuring out what z of alpha over 2 is, here they say determine the sample size required to have a margin of error of 1.55% body fat with a 99% confidence level, right? So we would have to go look up that confidence level, right? That is one of the ones in the chart, so it's 2.575. Okay. Sigma is 4.10. All right, and E, remember that's the margin of error. So they want a margin of error of 1.55. Okay, so 1.55 goes in there. All right, and then that quantity squared. Okay. All right, so go and calculate that out. 2.575 times 4.10. All of that divided by the margin of error, which is 1.55, and all of that squared. Okay, so I get 46.39 when I calculate that out. All right, but that is not quite the answer, right? Here we are talking about people, right, in this experiment. And so, you can't, survey 0.39 people, right? So what we need to do, right, is always round up to the nearest whole number. Or integer. You don't want to round to the closest one, right? The closest one here would be 46. We want to round up always on these, okay? Because 46 would not be enough to be bigger than this. It has to be bigger than this number, right, in order to do that. So the answer here, right, is 47. If you want to get a 99% confidence interval, right, for this population mean, what you're going to have to do is sample at least 47 people from this population. Okay, so don't forget to round up on that one. All right, and that's it for this one.